Question number 4 from the Release Applied Skill Items from the 2010 Algebra 1 ECA. And I think all that you'll need for this particular item is a ruler. So I grabbed a ruler, and you need a pencil. I'm going to use markers, but you just need a pencil. And I think that will be all that you need to do this problem. So let's look at the problem. Directions are pretty simple. Graph the inequality. And the key word here is inequality. Graph the inequality. Y is greater than the opposite of x plus 4. I'm going to write that a little bit bigger. Y is greater than the opposite of x plus 4. We are graphing an inequality, and that means that we will have a line, and we will have some shading, either above or below the line. So I think it's easier to think about the related equality. Y is equal to the opposite of x plus 4. Let's see what that line would look like, and then we'll determine whether the line should be solid or dotted. So if we look at this line, it's already in slope-intercept form, and it looks like the slope is a -1, and the y-intercept is 4. So I'm going to put a big dot on the y-intercept. It's 4. And then I'm going to use the slope to get the slant of the line. The slope is negative, so that means that there is a decreasing values as we move to the right. So I'm going to fall 1 and run over 1. That gives me a slope of a -1. I'm going to fall 1, run over 1, and I'm just going to have fun falling and running, fall and run, fall and run, fall and run. But notice that we get this continuous line. I'm going to pick up my ruler. What am I saying? I'm picking up my ruler, and now I'm determining whether or not my line should be solid or dotted. Because there is no equal to in the inequality, it's telling me that we must not include the values that actually make the line. So to show that, mathematicians have agreed to dot the line. And I'm doing just that. I'm dotting the line to show that the values on the line are not included. Now, we are not finished with this problem. This is an inequality, and what we need to do now is determine whether or not the true values that work, the solutions, are they in the blue question mark area above this boundary, or are they in the red question mark area, which is below the boundary? And the easiest way to determine that is to check a value and check the simplest one you can. Why work hard? So I'm going to go right there for one of the simplest points possible. And that point is, it has coordinates 0, 0. And I go back to the original problem. Y is greater than the opposite of x plus 4. And for y, I put in 0. 0 is greater than, and I also put in 0 for x, the opposite of 0 plus 4. 0 is greater than 4. That is impossible. That is not a solution because it does not make sense because 0 is not greater than 4. So it looks like the values that work are all over here. And we've learned in mathematics that a good thing to do is to actually test the value. My blue marker is running out, so I'm going to test the values with, I think this ink pen will work, we'll see. And we get y is greater than the opposite of x plus 4, and we pick any value over here. I'm going to pick 5, 2. So I'm going to make it real big, but that's the point, 5, 2. This is y, and this is x. So 2 is 2 greater than the opposite of 5 plus 4? Is 2 greater than a negative 1? And the answer is yes. So this does work. It's okay. And we have finished our problem. Now, you try some more on your own and keep practicing. Practice makes perfect. I wish you much, well, I don't want to use the word luck because it takes more than luck, but I wish you the best for the upcoming GQE, or should I say ECA. Whatever you need support with, this problem will probably assist you. Good luck.